Okay, so today we're going to be talking about dilations. It's the last transformations that we have to discuss. So, what is a dilation, right? Remember, a dilation makes something bigger or smaller. It's going to make a shape bigger or smaller depending on this thing called a scale factor, okay? This is the thing. This is what makes the shape bigger or smaller. We're going to figure it out right now. Well, if we're going from this shape to this shape, right? Well, we can see that the corresponding parts are AB and A prime, B prime. Remember that corresponding just means in the same position. Okay, corresponding just means in the same position. So if we went from 2 to 4, and then we went from 3 to 6, then how much bigger did A prime, B prime, C prime get? Well, from 2 to 4, I noticed that I could have added 2 or multiplied it by 2. From 3 to 6, I could have only multiplied by 2. So the scale factor here is going to be 2. So R is going to be 2, which means that the picture is getting bigger, okay? It's getting bigger 2 times as big. It's getting twice as big. So if it's getting twice as big, then how do I get from 5, what is this number right here? What is that number that goes there? Well, if my scale factor is 2, I know that my image is going to get 2 times bigger. Therefore, since my pre-image is 5, the corresponding part to that is going to have to be 10 because 5 times 2 is equal to 10. Okay? That's really it right there. So, how do I know if my picture is going to get bigger or smaller? Well, R, the scale factor, is bigger than 1. We notice, for example, in the case of 2, our picture got bigger. This means we're going to get bigger. If R is going to be less than 1, then what do you think is going to happen to the picture? Well, yeah, it's going to get smaller. If you multiply by a number that's smaller than 1, you get smaller. If you multiply by a number that's bigger than 1, you get bigger. And remember always what happens if you multiply by 1, well, nothing happens. It's going to stay the same. Okay, picture is going to stay the same. Okay, well, let's continue exploring this idea of a dilation because the picture is not always going to look like this. Sometimes it may look like this. And you say to yourself, well, okay, it's a dilation. What's my scale factor, right? What is my scale factor? And a dilation does not only have a scale factor, but it also has a center. Notice in the case before, our center was A because that's from where it extended from A. Notice our center here. Our center here is also going to be A. The picture is getting longer on A, okay? Or from A. So here, let's notice, what is happening? I can see that there are definitely two triangles. I have triangle A, B, D. I also have triangle A, C, E. Okay, two triangles. Now I'm comparing the corresponding sides. Remember, be careful here. The corresponding sides are AB and AC, as well as AD and AE, and lastly, BD with CE, okay? Those are my corresponding sides. Of course, my corresponding angles are going to be, here's one angle, here's the corresponding angle. Here's another angle, and here's the corresponding angle. And this angle is actually in both triangles. Okay? So that one is shared. And in a dilations, the angles do not change. The angles stay the same. The only thing that changes here is the measure of the side lengths. So if this angle is 20 degrees, then this one is 20. If this angle is 40 degrees, then this one is 40. Okay? The angles do not change in a dilation. But in this case, we're asked to find the length of DE. DE. So let's see if we can find the scale factor here. Well, I know that AB is 3, right? It's 3. So in order for me to find the scale factor, right? For example, here, I knew the scale factor was 2. How would I have gotten 2 if I did not know that the scale factor was 2 automatically? Well, one way that I could find the scale factor here is if I had divided 4 divided by 2, I would have gotten 2. But I could have also divided 6 over 3 and also have gotten 2. So in the general case, you're going to divide the corresponding sides to get the scale factor. So in this case, I'm going to be doing dividing the corresponding sides. Remember, it's going to be AC over AB. And if I do this, I'm going to get R. Well, that's the same thing as dividing AE divided by AD. And that's also going to get me R. Okay? Well, there's also one more, but since we don't know anything about this side or this side, we're going to keep it just like this. We're going to keep these two. And so we know what AC over AB is, right? We know that AC, careful here, AC is going to be 5 because 3 plus 2 is equal to 5, okay? So AC, this whole length here is 5. Okay, so it's going to be 5 over, well, what is AB? Well, AB is 3. Okay, well, that's going to give me some scale factor, and it has to be the same. These two scale factors here, these two have to be exactly the same. So this is going to be equal to, well, AE. AE, we don't know what AE is. AE is some X value that we don't know of. Okay, so this is going to be, I guess this side would be, if we knew what X was, it would be 5 plus X, right? 5 plus X. So 5 plus X over, well, what's its corresponding side to AE? AD. AD is 5, right? AD is 5. Okay, well, if we think back to middle school, how do we solve an equation that looks like this? How do we solve this thing? One of the things that you should remember is cross multiplication should come to your head right away. Cross multiplication, or the butterfly, right? So let's do that. Let's multiply. It's going to be 3 times 5 plus x. So 3 times 5 plus x is equal to 5 times 5. And on one side, we end up with 15 plus 3x is equal to 25. Combining the like terms, right? Let's combine like terms here. 3x is equal to 10. Right? 3x is equal to 10. Finish up, divide by 3, divide by 3. X is equal to 10 over 3. And what is 10 over 3? Well, you could leave your answer actually like that, 10 over 3, as an exact answer and be done with that. Okay? So keep your answer as 10 over 3. Okay, so if we have that x is 10 over 3, this little piece here is 10 over 3, and I ask you for, what is the scale factor? What is the scale factor here? Well, you're going to say, well, again, I'm going to go back and say that AC over AB is going to be my scale factor. That's one way to find the scale factor. Hey, and guess what that's going to give me? Well, that's going to give me 3 over, this is going to give me AC was 5 and AB was 3. So this is going to be my scale factor, whatever that is in your calculator. So 5 over 3 gives me 1.6, right? It's about 1.67, all right? And on the other side, I end up with, well, AE over AD, right? And that is actually AD, right? Check if you get here 1.67, which you should get 1.67, okay? And that's all it is. This is all about scale factors and when a picture gets bigger and when it gets smaller.